Welcome to our quick dive into the fascinating world of brain's response to motivation, reward, and stress. Imagine your brain is a bustling city, constantly adapting its roads and buildings to keep everything running smoothly to respond to whatever life throws. Let's start with motivation. As science calls it, motivational science. Think of it as your brain's way of shouting, hey, this is important. When something really catches your attention, your brain tags it as valuable, making you want to pursue it. Reinforcement learning then kicks in, helping your brain learn from rewards and punishment, kind of like a game where you get points for good moves and learn to avoid bad ones. All this learning happens because of synaptic plasticity, your brain's ability to strengthen or weaken connections between neurons. Two key players here are long-term potentiation, which is like turning up the volume on a neural signal, making the connection stronger, and long-term depression, which dials it down. Think of LTP as boosting a favorite playlist, while TD is like hitting mute on something less important. Sometimes stress throws a wrench in the works. Allostatic load, which is basically the wear and tear from constantly adapting to stressors, where too much can lead to neurosensitization, where your brain becomes overly responsive to certain stimuli, kind of like how a tiny noise can suddenly become painfully loud after a long day. The brain tries to compensate with upregulation, increasing certain receptor levels to maintain balance. One key molecular player is CREB, a protein that, when activated, helps turn on genes involved in learning and memory. CREB is like the brain's DJ, remixing the neural playlist to adapt and learn. Over time, a protein that accumulates with repeated stimulation, ΔFosB, acts like a chronic drumbeat that signals long-term changes in the brain circuitry. All these changes are heavily influenced by epigenetic regulation, tiny modifications to your DNA and histones that turn genes on or off without changing the sequence itself. It's like bookmarking pages in a book so your brain knows which part to read more often. Speaking of stress, it activates the hypothalamic pituitary adrenal or HPA axis, your body's stress command center. When stress hits, the hypothalamus releases corticotropin releasing factor, which kicks off a hormonal cascade, ultimately releasing cortisol. But in some folks, the system goes into overdrive with noradrenergic hyperactivity from the locus coeruleus, causing autonomic dysregulation. So in a nutshell, your brain is a dynamic, ever-changing organ, constantly balancing reinforcement, plasticity, and stress response. Whether it's learning a new skill, dealing with life stressors, or battling cravings, these intricate molecular and cellular processes work together in a delicate dance. Understanding this dance not only makes us appreciate our amazing brains, but also helps us develop better ways to support mental health and resilience. Thanks for joining this whirlwind tour. Keep your neurons firing and stay curious.